exactly where we left it off. I've not touched a tiny bit of code, which was basically modifying my other problems, the way I was naming things. Oh, bro, what did I just do there? Why did I make this no except though? It could throw. And this also could throw. I don't know why the fuck did I do that no except. And this could throw as well. Yep. Alrighty. Seems like it's okay. I got a little const going on there. Sure. Makes a fair amount of sense. And then again, makes a fair amount of sense. Do let me check out. I had everything set up. It's proper floating point numbers. I could change this to be a float value is going to be value is going to be s, well, we're going to use now GLS abs glm dot, the norm is z, the normalized z. Yeah, this was basically performing a base change when we don't know the orientation of the new base. So we do know the direction of the new base, but not the orientation, which is to say we don't know the yaw, pitch, and roll angles that we have to apply to the 3 rotation matrices for Z, Y, and X in the same order as the yaw, pitch, and roll convention. So yeah, I could do it in a flow, in a for, so it's more ergonomic. And go ahead and say if this is greater than or equal to 0.9f. Nope, this is supposed to be go outside. Nope. Nope. If this is greater than or equal to 0.9f and value is less than or equal to 1.1f, we're going to do that. We're going to have that, and technically I could then just go ahead, take all of this. Technically I go float value so long as float value is greater than that. I mean, seems like it would work. I do have to try it out though. So just let me, alright, yeah, I see something there, and that is I have to give this an F. What the hell did I just do? Select digits and add an F. I mean, no, add an F. No, Lord, add an F. There we go. Then to all of these digits, we're gonna edit dot f. Then if we're going to select 0 or 1, and there I say it should be alright. Now, the change that I'm most worried about is this one. So yeah, there's that. I'm pretty confident it's still gonna be alright, but what was ABS provided for? Because I think I don't have the include. It takes a vector in this case, common. So if I want this, wait a second. Common has ABX. Sure thing. So I have to import common. And that should about do it. Now that I say that, in problem 4, I don't use the absolute value. For real? Do I actually not use the absolute value? That's so nice. But in problem 1, I think I do. Nope. Nope. Well, that's nice. That's all in geometric. And yeah, there I say it is correct. So we got it there. We got everything going there. Nice. There I say this is the only one that I gotta try out, see if it works. I mean, I really have to check them out all again. So I'll do just that. Alrighty. Can I get rid of this? Nope. Alright, so let me go back to exercise 1 so that I know what the teacher is expecting. Alrighty. Lab 2. Wait a second. Right. So I'm gonna have to. Let's start with problem 1. So let me close the buffer with problem 4, problem 2, and problem 3. Let me move problem 3 to problem 3 to back. Let me move problem 2 to problem 2 to back. And let me move this to that. So now we only have one is the one that's going to get compiled. Yes, I know that is absolute garbage when it comes to building, but right now I am alright with it. Seems like everything is fair, so yeah, I'd say it's fair. Alright, now we had the scaling, the rotation, translation. So Really you're only switching, you're only, really you're, the way you'd set it up is like the way it'd be reversed. So you set it up this way and it will compute, you include them that way. So if you include them that way, the first one that ends up, no, the other way around. So instead of putting it that way, yeah. So it's actually first scale, then translated, then rotated, then rotated, and then, so first it's rotated, 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 then translated and scaled. It doesn't matter. If you're at the origin, switching, scaling, and rotation doesn't matter. That's the difference that the teacher's trying to show. Doesn't matter. Scaling it's not going to make a difference. If you scale first and then you rotate, if you're already at the origin, doesn't matter. What matters at the end of the day is that, wait, what? Well, whatever. Let's make, we get what we wanted, which was, well, you know, we can rotate, we can do that, we can do that. The key binding, I think we're scaling with A and Z, so A and Z to scale it. We can rotate the model. This way it goes the other way around. That's very odd. S and X. S and X are supposed to change the angle on X, right? But I'm just noticing there's something odd there. So, angle on X starts off at 0, just as angle on Y starts off at 0. By the way, this has to be 0, and the rest just applies the same way. Likely wanna keep it consistent. Only problem here being, if I'm scaling, no, I'm rotating on the x-axis, why is it that if I'm subtracting from the angle, and S and X rotates on the x-axis, so S so when we do it this way, we can, so when we add up to it, we can see how it moves. Let me displace it from the origin so we can see how it moves. But if I go the other way around, so subtracting from it, that's not the back, right? It's the same as this. We can see the inside of the teapot. We can also see the inside of the teapot there. So for some reason, when I'm issuing negative, so when the angle on X is negative, for some odd reason, in this case it's supposed to be key S, no, key X, it's supposed to subtract 0.1, but it doesn't do so. But when computing, nope. When computing the scaling, no, rotation on X. We're taking, let me check out the documentation. Rather, let me check out the rotation matrix in 3D. On the x-axis, these are using the right-hand rule. As the right-hand rule only works for multiplying r times x, the same matrices can also represent a clockwise rotation on the axes keeping the vectors unchanged. Right, sure. So on the x-axis, I'm going 1 and 3 zeros. Then for the second column, I'm going 0, cosine, and sine. And I think that's a problem. That's supposed to be the negative sign. No? Wait, what? No, it's correct. It's correct. What the fuck am I saying? It's 0 cosine sine, and then again 0 again for the W. Then for the third column vector, it's supposed to be 0, negative sine, cosine, and the 0 for that one, and the last one's got 3 zeros, and W is 1. So I wonder what the hell is it that is causing the matrix to do that. So when I perform for some reason this, see how we can rotate it this way, but we can't rotate it the other way? Actually, no, I think it's rotating. It's just that so let me keep track of at no point can I get it. This is so wrong. And I don't know why it is wrong. Oh, brother. So let's do it while it's still scaled. S and X. So we can see S. But when I go X, it turns straight to the other side. Could it be it's because of the order of transformations? Could it be it's because of that? So if I keep it model is going to be scaling. So what we change then is going to be translation and then the rotations. So yeah, dare I say it's correct, right? Maybe it's because of the reverse and that's why the teacher wants us to see that, right? Could be. No, that's not right. Like, whenever I set it back, it's like the Z is pointing towards us. So let me displace it a bit. Z is pointing towards us. As I subtract, and we reach back this point, if I subtract again, see how it's as if it was pointing now the other way around? That is very strange. That is very strange indeed. Why is it happening? I don't know. Yeah, I don't know. It's a good question that I have no answer for. Yeah, I don't know. Maybe they actually gave that as the notation and not as the code, and so I'm actually supposed to do first rotation of X, Y, Z, and then translation and scaling. I don't discard it. So let's go ahead and do it. And then it would be translation, and then we would have scaling. So this goes away, this goes away. Translation and scaling. For some reason, when I rotate on the x-axis, when I rotate around the x-axis and I go down, instead of having the z-axis, you'd expect that if I add to it, if I rotate positively, it goes that way. If I rotate negatively, it's not supposed to go that way. It's as if the z-axis switched directions. And I think that's wrong. Yep, pretty confident that's wrong. Uh, um, Oh, it does say I'm only supposed to apply scaling to the x-axis. So I'm only supposed to apply this to the x-axis. So maybe that's the reason why, or not. If you only apply it to the z-axis, you end up with this. And if you rotate, for some reason the z-axis like switches directions. I don't know why. Generally don't know why. It like switches directions. When I start decreasing, the z-axis, see how it's pointing towards us? As I now rotate in the opposite direction, it sort of reverses itself. And I don't know why is that happening. So we have found a new issue. So if you apply rotation, then transformation and scaling. Still odd. Still really odd. Maybe it's some other rotation I'm getting wrong. Pretty confident I did not get that one wrong. So cosine and then sine and then 2 zeros. Then negative sine, cosine, and 2 zeros. And basically 0, 0, 1, 0. And 3 zeros and 1. Because we're in affine. We're performing affine transformations on the world coordinates. So, on y, technically it's still correct. We've got cosine 0, negative sine, and other zeros, and this is 0, 0, 1, 2 zeros. And we got sine 0, cosine, and then another 0. And then finally 3 zeros and a 1. Makes sense to me. Geometry, multiplications, ambiguity, no. Yep. I don't think there's anything wrong. Yep. Pretty confident I don't think there's anything wrong. So I'd like to know why is it that when I subtract to the angle, probably want to also apply that scaling. I mean 1f, no, 0.1f, 0.1f, 0.1f. First and foremost, you'd scale it, you'd rotate it, you'd scale it. And you translate it, right? Scale it, rotate it, and translate it. So A and Z make it smaller and bigger on the Z axis. And for some reason the Z axis turns around. I don't know why it does that. It's like the Z axis sort of switches directions. The vector denoting the z-axis switches directions, and I can't explain why. Yep, I really can't. I genuinely can't explain it. And the teacher's not really saying anything about it. Sure. Sure. Whatever. Whatever. Basically, we just manually implement the... Still, what I don't get is why is this happening? That's not the way the x-axis is supposed to rotate. That is absolutely not how it's supposed to rotate. Could be I forgot about some break here when I'm adding and subtracting. So I go key right, key left. Scaling is what makes it more. Yeah, I don't know. Say I move it so out of the origin, I rotate the x-axis, so FV. So I rotate the x, yeah, basically. Simply what you'd expect. But not quite. Possibly because of the order of transformations. They literally just want me to do it that way, so I don't know. Let's see. Let me get rid of this. So we get translation. We scale the first one, and then we scale the next one. We translate, we rotate on Z, Y, and X. So that makes sense. Makes a fair amount of sense. And that is perfectly, not quite perfectly. It's an approximation, so it's not quite perfect. Technically then, nah, it's really odd. The way it's rotating on the x-axis, it's really odd. So if instead I do it with I translate first, I rotate, and then so I rotate first, but on the, yeah, same, ZYX, and then scaling. So I make a translation. If I make the rotation, it's supposed to be correct. if I make scaling supposed to be correct, this is extremely odd. Because when I scale an x, it doesn't quite do it right. I don't know what's going on, but the rotation on x, either it's very odd or I'm not understanding the rotation on x quite right. 0 cosine sine 0. 0 negative sine cosine 0. I'm using trig. Should yield, really. Angle. Let me check out the 6 in a vector. Alright. Negative 1 to 1. Dare I say that's correct? It's being provided standard cosine, provided some angle. Let's try it out. That's the STD ones. It's not doing it right. Not rotating right on the x-axis. The rotation matrix on the x-axis is wrong. Completely wrong. But I don't know why is it wrong. I genuinely don't know. At least we can safely assume it's not because of this. So I can go back to using the GLM. So when I move it a bit and I go S moves in the right direction, but X for some reason, as it starts subtracting, it sort of reverses the Y-axis, the Z-axis, and I don't know why that is happening. I genuinely don't know. It's just nonsensical. I mean, I know this is the functions are implemented the way the teacher expected us to implement this particular functions because it's just returning a matrix with, that is, the rotation matrices we've studied. I mean, the transformation matrices we've studied, but X is not reading right. Let me look up on the internet because this is simple. I can't really see what could it be that is wrong. And yeah, that's it. Yep, I don't know. rotation on the x-axis. No, negative rotation on the x-axis reverses z-axis. So what does it say? Rotate x and y around the z-axis. Rotate y and z, and rotate x and z around the x-axis. I genuinely don't know. Around the z-axis. I don't know, brother. We've got the vector, some sine, yeah, I don't know. All right. Span the matrices to 5 by 5, replicating x and y rows, columns in the order x, y, z, x, y. So, yeah, dare I say, seems fair. Yeah, I see the blocks. What I don't get is, why is it that I'm rotating around the z-axis, so it's as if I had, if the z-axis was pointing towards me, and this was the y-axis, and I was rotating towards this side. This, what I would expect would be for this to go like this and not to automatically switch and then go like this. You know? But it automatically switches and goes like this instead of going like this. Let me see how GLM implements the rotation matrices. So let's look up the repo. Oh, what the hell is this? Alright, sure, whatever. What I need is looking up. Oh, Lord, sorry for that. What I need is, yeah, I was looking up the rotation, so I need the implementation, which I believe is either in ext or somewhere else. I think it's in matrix transform.inl, which should be right there. Here's the implementation as a matrix transform. So for the rotate, it takes a constant type t being the generic type for the type that we're using, Q being the precision, so T is technically also the precision of the floating point type. Rotate takes a mat4, that is a constant reference, so a reference to const really, and a 3 vector, which is indeed as well a reference to const. Sure. Matrix is M, the vector we're passing is V. Oh yeah, and in between the angle as well, of course. So it makes A be the angle, and it computes the cosine of the angle and the sine of the angle. It pre-computes those. Then it makes a new axis vector where they normalize. My God, I did not expect this to be the case. Yeah, no, the thing is the rotation matrix takes in an innocent matrix. But when you're making a rotation from scratch or really any transform, you pass the identity matrix, so a GLM mat4 with, well, depending whether you have the force constructor, no premium, whatever. There was a flag that you can pass. I don't remember anymore, but you can pass it so that if no constructor, so that it enables default constructors where without an argument it constructs an identity matrix. But if you don't, then it will construct the null matrix, and so you have to pass it a single scalar. I mean, it's not a scalar, but it takes it as a scalar. The parameter is a scalar. That it will interpret as the main diagonal. If you pass in one, then you get the identity matrix of whatever matrix constructor you just called. A mat4 will give you dimensions 4 by 4. I'm assuming it does this because it can make no assumptions over the given matrix, so let's just assume we passed in as the first parameter the identity matrix, which would give us the standard rotation matrix with the angle applied, so technically we've already computed the cosine and sine of the angles. It normalizes V, so if V is not normalized, it gets normalized in the range of minus 1, 1. Yeah, I think so. Wait a second. Passing it in a vector. Alright, yeah. In the same direction as x, but with length of 1. Yes, of course. Sure, so you get the vector, and yeah. Yeah, that's about it. Sure. you get the rotation matrix. For rate of rotation in x, the vector would be 1, 0, 0. So you get a vector that points towards 1. Yeah, well, basically points towards 1. That's not much more to it than that. In a right-handed coordinate system, so like this, you'd go x, z, y, as we do and as OpenGL does. So right-handed coordinate system. It then takes a temp where it initializes with a type. So in this case, the flow is single precision floating point numbers. 1, so it converts 1 to a floating point number. It then subtracts to it the cosine. And it then multiplies that by some axes. Oh yeah, by the axes we just got. So something minus the cosine of the angle times the axes. And it uses that temporary at some point down the line. I mean, let's keep reading. We then have the rotate matrix, which basically takes, alright, so I believe maths have the brackets operator. It's not the brackets operator, but the indexing operator, I think it was. Basically the brackets. They're overloaded so that instead of following row major order, they follow column major order in GLM because GLSL follows column major order. And so it go at column 0, row 0, it takes C being the cosine plus the temporary, which in our case would be 1 minus the cosine of some angle times the axes, where the axes is the normalized vector, which would still be 1, 0, 0. And that is another vector. I believe that to be the dot product. I think it's overloaded to be the dot product. Yeah, it's definitely the dot product. Wait, no, was it dot product? No, it was scalar product, right? Yes, it gotta be. Oh boy, I'm tired. Scalar product. Yeah, scalar product, dot product. Yeah. Yeah. Dot product of a scalar and a vector. Sure. So scalar times vector. No, it does scalar multiplication. No, dot, not dot product. Scalar multiplication. Oh my god. Yeah, scalar multiplication. That yields another vector, basically. Yeah. In a common geometrical context, scalar multiplication of a real equivalent vector by a positive real number multiplies the magnitude of the vector without changing its direction, and is to be distinguished from the inner product of two vectors where the product is a scalar. Sure. Right, of course. Alright. So that gets us the scalar multiplication, and it yields some value. Not quite sure like the way they do this, but yeah, let's keep reading. So the rotation matrix is going to take column 0, row 0 is going to be the cosine. Oh yeah, right. Oh brother. A problem is that Oh, Lord. That temporary is supposed to be, so 1f minus the cosine of the angle. So if the angle is, say, wait a second. Let me replace this. The fig rod x by a GLM rotate that gets the identity matrix, the angle being on x, the vector being 1, and then 2 zeros. Technically, that should produce the same matrix. Right, so it's not that I'm getting it wrong. Is that any rotation does that. So, because even with GLMs, I'm rotating now on the x-axis using, yeah, alright. It's reassuring to know that I was not doing it wrong. Yeah. At some point, I'm likely gonna need to read this again, but for now, let's just say I don't know what temp is. I don't know. I mean, it's obvious they're trying to generalize this, so it's useful for any axes, but it's a bit hard to think about it, because if you think about the expanded, can I get this? Oh, Lord. There we go, that's better. I'm assuming it has to, let me move this window nearer and let me close this. So it gets a floating point number. Let me get dark mode on this because my eyes are dying right now. So it goes cosine times axis 1 plus s being the sine. So it takes column 1, row 1 is sine of sine of the angle times axis 2. Because it's normalized, it's either 1 or 0. Let me go back to the standard notation. I mean separate notation. It only considers, of course, the first 3 columns and first 3 rows because, the 3 rows of each column, because the other ones are just like the filler for the W component for world coordinates. Alright, so it takes axis 1, so if I'm rotating around the z-axis, it assumes 0, 0, z-axis should yield cosine of theta, and that is always the case. So if you actually look at it, you realize that position 0, 0, 0 is always either cosine or 1. Thus, to get that, you get the cosine of the angle plus the temporary temp times the axes. If we're rotating around the z-axis, axis at 0 should be 0. So you only compute the cosine, and this is 0, so it cancels out the vector, and you end up only with the cosine of the angle, which is exactly what we end up with in the transformation matrix for a rotation around the z-axis. Then, I'm trying to wrap my head around, I'm assuming temp is like the extra thing that we need to decide which one of these we're going to end up with. And it's likely something mathematical I'm completely missing, but I have to try out. So now column 0, row 1, so now we moved here. Technically it'd be like stride 4, 8. No, it'd be stride 1, 2, 3, 4. It'd be stride 4. Right? Yeah. It'd be a stride 4 axis if we were considering row major order and low level computations. Either way, it's overloaded, so it's likely that internally it's storing it in row major order, but it exposed an API that is akin to GLSL's API. The rotation then is axis on 1, so if we're turning around the z-axis, that should yield 0 as well, so cancels out temp. And then it adds sine times axis 2, axis 2 being y. If it's 1, then we end up with a sine. And wait a second, what the hell? If it's around the z-axis, oh yeah, axis 2 is, well, wait a second. Axis 0, yeah, axis 2 is z. So 1, and so the sines times 1 ends up being the sine of the angle. Correct as well. I have to reach some point where temp is what decides what exactly do we get as the right angle. Now, we're right now here. We need a 0. For that, I'm going to have to take temp times the axis at 2. Axis at 2 would be 1 because we're rotating around the z-axis. We're only considering the z-axis. Minus the sine times the axis at 1. Now the axis at 1 is 0, so it cancels out the sine. And so then we would need temp 0 to be 0, because axis at 1, axis at 2 is 1, as that is the third axis that we pass in the vec 3, indicating the direction, indicating the axis around which we want to perform a rotation. In this case, if it's we're simulating rotation around the z-axis, so axis 2 would be 1, and so temp 1 should yield 0. Yes, it's noticeably enough. Temp is always multiplying by the axes, and so is deciding whether the axis is to stay or not. Thus, temp 1 ought to be 0. Temp 0 ought to be something. Let's say we had passed 45 degrees. So basically pi on 4. Cosine of pi on 4 yields square root of 2 on 2. 1 minus the square root of 2 and 2 is around 0.3. 0.3 times the axes is a scalar multiplication that multiplies by all the components of the axes. The axes has normalized every single one of them. So why exactly is that the case? I mean, cosine of pi on 4 is pi is square root of 2 and 2, which is around 0.7. 1 minus 0.7 is around 0.3. 0.3 times the axis should be 0, 0, and then 0.3 times 1 if we're trying to rotate around the x-axis as we've normalized the vector v, and we end up with 0, 0, 1 if we didn't normalize it previously. So it ends up being 0, 0, 1 times 0.3. 1 times 0.3 is 0.3. Temp 1 is also 0, but temp 2 is 0.3. If I didn't get this wrong. Temp 2 multiplies by the axis 0, so it really yields 0. On the second one also yields 0, and so you end up with positive sign times axis 1, which is 0, 0. That is correct. And lastly, axis 2 is 1. Temp 2 is 0.3. And the cosine of 1, and the cosine of, as we were saying, pi on 4 is square root of 7. So I have square root of 2 on 2, which is 0.7. Oh, I see now. Right, and so it completes it. Right. Clever trick you got there. Props. Clever trick you got there, my man. And clever trick you got there. Yeah. I get why temp is that way, and yeah. It completes it because then at the end here, axis 2 is 1, temp 2 is 0.3, 0.3 times 1.3, cosine of, in this case we were considering pi on 4, cosine of pi on 4 squared root of 2 and 2, that is around 0.7, 0.7 plus around 0.3, ends up with 1, which is exactly what we end up with here. Of course it's all an approximation, but yeah. I understand, and props to you, it's a good generalization of the process so that you don't end up with a massive function that assumes the standard rotations that we mathematically know. Yeah, all right. That's nice. That's really nice. Of course. And of course the result is basically just, it adds it up to the, So this is really the standard one, and because if you pass the identity matrix for the result, it's basically adding it up to, it's multiplying it by the, performing a multiplication with the identity matrix, and if it's the identity matrix, then we basically get the same as with the rotate function. The rotate matrix. So result ends up the same as rotate if the matrix that we pass is the identity matrix as we do in all exercises. All right, I get it, and that's a clever trick. All right, so we solved that, or rather, we now understand how they implement it, and at least I know my solution is not wrong, because implementing it with GLM's operation still yields the same values. So yeah. Last check. Everything seems correct, and yep, we can move on to the next exercise. I mean, no, we can move on to checking up the next exercise. They're all done already. So we're gonna now rename this one to back. We're gonna rename to what it was. Problem 2, let me check real quick. Yeah, I already made the changes. We had everything there. Yeah. Problem 2 wanted me to perform these transformations. Basically, you end up doing translation, scaling. Yeah, you know, the average. The rotation around the y-axis, then the rotation around the x-axis, and then the rotation around, the rotation around the y-axis first, z-axis, x-axis, and yep, yxz. That's how it's done. So I do, we get it. So if I stop this from being a floating, if I make this a floating window, it's technically accurate. The teacher wanted this. He wanted this, and I got this. So it's as accurate as it could possibly get. So that's done. Let's move on to exercise 3. If it works, we can move on to exercise 3. Let me make a quick look up here. I didn't miss any styling stuff. Alrighty, all the numbers follow the same formatting. I love. Yep. Seems like they do. Nice. Alright, then. We can close this buffer. We don't have any buffers open. And we're going to rename the second. We're going to rename the third back. We're going to build it. Let me make this a floating window. So exercise 3 expected it to turn out like this, and it did turn out like that. So nice, we got it. Basically, this was simply performing a base change so that the z-axis now points. It's a base change of the z-axis, so simple stuff because it's assuming we don't have orientation, but we do have direction. Meaning we can't use yaw, pitch, and roll, but we can use normalization of the z. We can make a new right-handed orthogonal coordinate system with new x, y, and z values as vectors. We compute the z value as the normalization of the direction of flight. If the direction of flight is determined to be the previous z-axis, then you simply if the direction of flight is the new direction, then you simply normalize the new direction, or you have the new z-axis. Once you get the new z-axis, then you just get the y and x. You then get the x you make an approximation to some global axes. You get the dot product with the z. You then get the absolute value of the you normalize the absolute value of the dot product of z times some approximation to some axis. So like z times the new z times 1 0 0, 0 1 0 if you want it on the y-axis, 1 0 0 if you approximate on the x-axis. If that doesn't yield something near 1, then good. You can use you can then multiply You can then perform the cross product of that times the good question. I forgot, but let me look it up real quick in my code. So if it works, and this is the thing that I needed to try out, which it works, doing it with a for loop instead, it's more ergonomic. I mean, it looks better. Do let me indicate to the teacher, this is empty. No, Lord, will you fucking... Little trick with a for, so that we scope the value of which we're getting the absolute value of. You get the absolute value of the product of norm z and the global approximation. If that is, well, I make, of course, here a bit of a floating point thing. It's short circuiting, so I can rely that the second comparison to 1, 1 is going to be with a new value for the floating point number. And of course, I keep switching. That's basically, it's just basically little logic to switch different values for the global approximation to different axes. And then you normalize x by normalizing the value, of the cross product of the global approximation and z. So yeah, I was correct. You get the cross product, normalize it, you get x. Because x and y are already normalized, you can simply compute the cross product and get y. And instead of having to normalize again, because z and x are already orthonormal, you already get an orthogonal system. So all vectors are perpendicular to each other, which is exactly what we want. And with that, you have performed the base change. So yeah, it does that just fine. And it's nice. Here we go. Now, once we have that, and I think I'm doing everything the way I like it, let me check out the style. Am I doing things exactly as I like? The style is correct. All right, I love what I see. Style is all perfect. Beautiful style. I really need to get C-line tidy configured, because I had it configured, but for my own personal needs, not for the way college expects me to do it. But yeah, the first scaling, because for some reason on my screen everything looks massive when I initialize an OpenGL. Haven't looked into that, really haven't bothered much. GLM forgets me to normalize X, and yeah, basically it makes a new that, which applies the final transformation, which is simply, whatever, pretty obvious. It's all pretty obvious, pretty damn obvious. You make the translation and you compose it with the rotation. The rotation is, instead of the standard rotation, it's based off of the vectors you just got on the new base, where you make a 3x3 matrix where each column is the vector x, vector y, or vector z with each of its components there, and then you add the extra row, the extra column, and the extra component per column for the W component to consider world coordinates with W1. So yeah, that's what I do here. Nice. That's done, and it works. Because we already saw exercise 4 worked, then we can move on to Unity, which is indeed what I hate most. Or rather, it's the only thing I hate. Everything else I love. Unity I hate with as much as I can, basically. So that's done, and this is done. Now that that is done, I can, let me close this, let me go here, let me go here. And now that that is done, I can just get out of here, really. Let me go ahead here and move this GeoGebra export to source lab 2. And let me move this back to being full-on problem. Lab 2, problem 3, problem 4 is going to go back to being problem 4.cc. Lab 2, problem 1 is going to go back to being that. We got our previous things. Let me move back lab 1 to source. And there we go. We have our labs exactly as we needed them. And now I have to, let me quickly make it clean, get status. Yes, I forgot. I had to edit the libraries, the custom libraries that the teachers made and I changed. Yeah. So let me make a split. And let me open up the other one here. So we've got the extern there, which is for that one. And of course, libraries that I documented and the teachers did not bother documenting at all. Yeah. Alright, so we have the vertex, we have the position, the normal, and the UV coordinate textures, whatever, who gives a fuck. That doesn't matter right now. The mesh GL, sure, whatever, stores the vertex, the vertex array object, vertex buffer object, element buffer object, and the index count, which we use in the final call to draw triangles or stripes or lines or whatever. Then the destroy call, which is funny because I don't think I've ever seen it used in the entire library. For some reason, I saw that it was there, and I was like, why exactly is it that we have this here? Not quite sure why we have this here. And what can I say? I don't know why is it that we have this. Yeah. I'd say it'd be best if we just made a destructure for the MeshGL struct, seeing how it's fundamentally, and in this case it's an aggregate class, so it's all public. They all have in-class initializers, and on top of that, I'm not sure if it's a good idea to make it a destructure. See, the destructure is triggered before the elements are just the data members of the class are destroyed. So I still have the unique identifier to the VIO, the VBO, and the EBO for the internally stored OpenGL VIO, VBO, and EBO of a specific mesh. That is, they're not reset. So instead of resetting them myself, thing is, I don't know if at some point this is used explicitly. And it may be because, I mean, I sure as hell have not seen the teacher use the destroy function in the library, but I've not checked out the rest of the labs that we have in the semester, so at some point they may require us to use this explicitly and not following resource acquisition initialization, the pattern. So yeah. For now, I'll leave it this way. If by the end of the semester I see that we don't use it, I'll refactor this part and make it a destructure, like the destructure for the MeshGL struct. And if not, then, well, it is what it is. Either way, that's just what it is. We can now move on to the load model as single mesh. Let me make that it gets a standard string. Probably better idea to pass in a standard string view, at least according to Bjarni-Strostrup's recommendation. So string views, or rather, it's in the advice for this chapter. Use string to own character sequences. Prefer string operations to C-style string functions. This is, of course, true of C++ 17, because unfortunately, we use C++ 17. Well, at least it's better than last year. We used C++ 11, but still, whatever. Doesn't matter much. As Bjarni Strostrup himself said, there's two types of languages. Those that are dead, and those people complain about. So those nobody talks about, and those people complain about. Yeah. So, use string to declare variables and members rather than as a base class. Sure. Return strings by value. Rely on move semantics, so copy-elision. Directly or indirectly use substring to read substrings and replace to write substrings. Sure. A string can grow and shrink as needed. Use add rather than iterators or the index operator when you want range checking. Use iterators and that rather than add when you want to optimize speed. String input doesn't overflow. Use C-string to produce a C-string only when you have to. Use string, whatever. Use string view as an argument of functions that needs to read character sequences stored in various ways. I mean, I don't need to own it, so this would be same as a... I forgot already how it was in Rust. But yeah, I'd say string view should be... The problem is imported only takes a string. I love this. Takes a constant character pointer. So of course, I can't pass path and expect it to use a constant character pointer because it's already sort of like a view to a string which has an underlying constant character pointer. Yeah, it's gonna have to stay constant standard string. Yeah. Path by value, so sort of acting like a string view. At the end of the day, we only use it as a path. It'd be great if I used file system path, but I don't know how much refactoring I'm going to need for that, because even the current lab I'm going to have to change if I do that. Oh, shit. Alright. Let me check out if read file has some overload to accept file system paths. I mean, even if it doesn't, file system paths have a function to return a string, and that can be cast into a constant character pointer. So, yeah, I suppose. So it's more of a pointer to a const character, rather. It's not that the pointer is const, it's that it's a pointer to const character because it's high-level const, not low-level const. There's a difference there, by the way. Now, alright, so we have a file statics. What am I saying? No, that's not the point. The point is I have to replace path with a file system path instead of a string, because that way I can make a little assertion and I can throw if the path doesn't exist, and I don't have to put a precondition on the documentation without an exception that is thrown in case the precondition is not held. And that would be great. So let me check out the info and file system. So according to tour of C++, most systems have a notion of a file system, providing access to permanent information stored as files. Unfortunately, the properties of file systems and the ways of manipulating them vary greatly. To deal with that, the file system library and file system offers a uniform interface to most facilities of most file systems. Using file system, we can portably express file system path and navigate through file system, examine file types and the permission associated to them, whatever. I've used it before, and what I need is not to read this. What I need is to look at the reference. What am I doing to it? Oh, Lord. Also, why am I doing this when I can do site cppreference.com file system? Is this what I need? The file system path. It's the class that I need. So, it defines returns the native version of the path. So that's nice. I can use it. Is the operator string type explicit? No, it's not. That's beautiful. Okay, that's absolutely beautiful. Because I think there were only like 3 or 4 conditions where even an explicit conversion operator could be used implicitly, and I don't think string types. I mean, it's not string type. It's string type is likely the alias that they're using for string. Let me check out the standard. So file system, header file system synopsis. Where's the operator? Not that one. Output stream, input stream, UA path, file system error, entry iterator, begin end, class recursive directory iterator. Enum class. All right. What was I looking at? String type, yeah. String type. Shouldn't that be at the start though? It's where they have the using things. The type aliases. What the hell? Conformance, normative reference, terms and definitions, namespaces and headers. Class path. Oh, there it is. String type, basic string with a value type. The value type, well, it's a const expression valued, no. See below. See below being I was looking for a value type. See below. Class path is used to support the differences between the string types used by different operating systems to represent path names and to perform conversions between encodings when necessary. An object of class path represents a path and contains a path name. Such an object is concerned only with the lexical and syntactic aspects of a path. The path does not necessarily exist in external storage, and the path name is not necessarily valid for the current operating system or for a particular file system. All right. I'm going to assume string type is a system-dependent basic string. So yeah, I think. I don't think C below would mean C really below. Path conversions, path iterators. Maybe it's in the path constructors. All right, whatever. Yeah, it'd be nice if this got past a constant std file system path instead. Now that does mean we have issues with one little thing called this would cause issues with, well, then it basically checks same check as we get in the documentation, except for some reason the teacher also added this check, which was if the scene does not have a root node. I mean, not if it doesn't have it. Root node is a pointer itself. If it's null, basically, if it's null, we throw the standard a runtime error. Yeah. Converts it into a string. Sure, whatever. And yeah. Alright, sure. Makes a vector for the vertices, the indices, and gets a mess. Oh god, gets a mesh. All of this, there's nothing to touch here because this basically traverses the scene graph, checks if this got normals, texture coordinates, stores those in the UV coordinates, stores the normals, you know, this stuff. Checks again if it's got number of faces so that it stores indices, the usual. Then generates a vertex array buffer, generates for both, the vertex array object. Then the two buffers for the vertex and element buffers. Then it binds the current active VAO to the mesh's VAO. Binds the current active array buffer with the VBO, the element with the VBO, loads up the corresponding, the type of thing. Declaration type of parentheses, value type, yeah, whatever. The usual stuff. Nothing strange here. Nothing that I have to change. It's unfortunate that I have to return data as a pointer to this, but being a C-compatible API, it accepts a pointer and not like a full-on data structure. If anything, I can say I'm grateful the vector API, even if it's because it's a resource handle, it allows me to return the pointer to the first element in sequential memory where the thing is located. That's nice. Then we enable the vertex entropy rate 0, and we enable 1 and 2. On 0, we store the vertices. On 1, we store the 0, we store the position. 1, we store the normals. 2, we store the UV textures, I think. Yeah, that's why we also use the offset off operator. Then we unbind the vertex array, so we leave the active VAO free for the next time we want to draw something on screen. Load up something on screen that is not the mesh we just loaded with async asset importer. We update the index count, which was that other GL unsize I platform independent type that we used for the number of indices, and we use wait a second. It was size I, so it was assigned integer-based size type and not an unsigned integer-sized size type. And we get the size of that, of course, and then we finally return the mesh. I don't think I have to change anything else from the last changes that I made other than that. I do believe I have to perform the check, so the usual, make the try, take path, or rather, take if path, is regular file path. We're gonna throw file system error. Here we're gonna have the string, and then we're gonna make an error code, which is gonna be rc is going to be no such file or directory. Then the string is going to be this one. And here I'm supposed to, oh Lord, what am I doing? What am I doing? Wait a second, let me replace this with this. Let me make a string real quick. Let me add to this path str. This would not be possible, but this is possible. And so that happens. That is the what, so I tell it that the what of the exception is that one, and yeah. In this case, we're going to be catching the exception, so yeah, we want to catch the exception because it's recoverable within the body. Is it recoverable within the body though? It's not. I don't really need to make a try-catch block here. The try-catch block is supposed to happen wherever it is that I call it from, seeing how it's only supposed to be used on the Fig teapot, Fig airplane, and Fig, well, unit circle, unit cube, unit cylinder, I think it was, and unit cone. So yeah, I'm just going to get rid of this, and I'm going to get rid of this. I'm just going to add this so that it checks that it's a regular file, the one that we get passed. If it's not, then we're going to do that, and that's it. Now, this may throw two exceptions. The first one being a std file system. I'm best off copying it. The second one being a std runtime error. So for the file system error is going to be we didn't find the file, so for runtime error is going to be the scene graph didn't load. So yeah. The precondition is going to be, as I said, the directory has to be valid. I'm going to have to change this precondition because it's different now. So yeah. And the other precondition is going to be, yeah, that's it, really. That's the only precondition. So he updated the pre with the exception, and that's it. Now, I do believe the description of the function also needs changing. Loads a model with libasync, returns the mesh with a VIO, VBO, and EBO configured. Why do we keep the VBO and EBO bound to the active array buffer and element array buffer? This is odd. It's not here. Is it here? Nope. Nope. Absolutely not. No, of course not. Where do I set it, dude? Then I unbind the vertex array. Alright, yeah. As much as it pains me to say it, it's alright. Yeah, it's alright. C-log isn't assigned to anything, so inlines should be alright. Even though, yeah, should be alright. So yeah, with those changes and the ones I made here to use, well, let me quickly disable inlay hint. This should be correct. We load up on 2. We load up 2 components because of the UV coordinates, the texture coordinates. It's flow type that we passing. We don't want to normalize. We pass in the size of the vertices is value type, so the size of is single element in the total structure that we're going to pass. We reinterpret cast, so we tell it, trust me, bro, I know what I'm doing, basically. No good using reinterpret cast, but the alternative was using C-style cast, and I prefer to see that I have a cast there that is dangerous, even though it's how it's supposed to be used. The function is supposed to be used this way. So a void pointer, and I compute the offset of UV and the structure of value type. The structure of vertices of value type is vertex, and so it computes UV. Technically, knowing it at compile time, I could avoid this by simply saying, hey, it's at this offset, considering, well, that would also be assuming I know the size of this, and I know the size of this, and I know that it's not padded anything, so that in memory it doesn't stay halfway through one block and halfway through another block. Oh well, offset off is okay. Offset off is okay. Offset off should do just fine. It's done just fine so far, seeing how we've used all these functions to load the models. So it'll do. It'll do. Alright. So it leaves both the array and element buffer bound to the message active buffer because it's automatically unbound again whenever we, yeah. Alright, so moving on to this one. Gets the mass, makes it a static, loads it up only once if it's not a static. Yeah, the path is going to be models t-bar-glb. Fortunately enough, path accepts being constructed as a string, which is good. If everything's alright, then I use C-log, and I pass it endline because C-log is not flushed automatically. In fact, let me check up C++ primer. Well, I don't think C-log is mentioned here, and if I go to the index of true C++ and I go to the C, B, C, and I go CL, nope, C-log is not there. Maybe log, no, let's go to the L. Log, but it's not log as in logging, it's log as in mathematical log, right? Yeah, it's log as in mathematical log. Yeah. So basically it does that. Because it's not an error, I can just use C-log. Before this, I think it was using C-error. I don't need to flush it here. I can just also return early from a function. If the mass VAO is not 0, that is, we can bind it to the active vertex, draw its elements with the index count that was already updated when we build it. NSE start at 0, so the offset is at the very start of the structure. We use unsigned ends because that's the type of the indices. vector, and we use triangles methods, and use the triangle method. Mode. Cool. Nothing to change from this one. I do have to catch another type of exception and make it that it's above this one. So I can make const std file system error e and use CR. And let me paste that there. Let me get that there. So yeah, uses that basically. Secondly, this doesn't change the interface. You still call this function fig teapot to draw the teapot. And only now it better handles the possibility that you don't have the model stored on this specific path. And yeah, that's it. So we catch that exception. We use error, CR, we return. There is another problem, and that is, oh Lord. There are multiple problems, but the main one is that technically when I catch this and I return, it doesn't get called. But when I return from this, the exception just stops here and it's assumed to have been recovered. But it's not been recovered. If the model is not there, we don't just return. We're supposed to throw back the we're supposed to handle the issue here and report to CR, so the standard error, and then I'm supposed to send it back up to wherever it is that I call fig teapot. Because this way it's just early return. And the next time in the rendering loop that we call display, and display, which is the function we always use in the rendering loop for all of our business logic and the actual problems for the labs, I use fig teapot. Next time it gets called, the mesh VAO is of course still going to be 0, is going to try to load it again, and hey, guess what? Another error. Yeah. This is not good exception handling. This is supposed to throw again. If anything, it should throw the same one. And then, whatever it is that I've called fig teapot, throw again. Have a try-catch block, because this can throw. And if this throws, sure, mesh is still 0, because we did not alter its value, as load model did not, load model just jumped the exception, but that just means it's going to continually try to keep loading it up, CR, EWAD, CR, EWAD, CR, EWAD constantly. And that's not what I need. What I need is to throw back the exception or throw some other exception, maybe a standard logic error, because after all, we've already handled this by reporting it to CR, basic handling, but it's all we really need at this point. And then here, I'm supposed to throw maybe a logic error. So say, still, technically that already throws it, so if it's reported, there's no need to. No need to, because this already reports that the model has not been found. Sending another logic error with model hasn't been found again is like, no need to, just send the same one. So throw again, and that's it. And if it's some other one, the only other one being, I don't think any of this can throw. Maybe some of this can throw, but I trust it's not going to. And the only one that is explicitly going to throw is if it jumps the runtime error because the scene graph did not load correctly with the asset importer. So yeah, uh, yeah, it's supposed to throw again. That's all. It tries, it throws, it reports. Once it reports, it throws back, and wherever it is that we call fake teapot, if it's through, we don't even have to try catch, because if it's through at some point, you may as well just terminate the application. If it's not found there, you're cooked. If it's found there but the asset importer failed for whatever reason, then I would have to look into what could be the possible reason that async fails to load a scene graph. If it could be something related to memory, then maybe it's worth catching the exception for that we throw, so the runtime error that we throw if async doesn't load correctly, the scene graph, and retry it on the next iteration of the render loop within whatever function that we have fictbot being called from. But for that, I'm going to have to check out first asset importers. So async, yeah, async, and that's it. My God, my eyes are gonna die, dude. Alright, documentation. It was working with the asset import library, accessed by C++ data structures. So it can be accessed as both a class or a flat function interface. The C++ class is the preferred way of interaction. You create an instance of the class async importer, maybe adjust some settings of it, then just call async importer read file. The class will read the files and process its data, handing back the imported data as a pointer to an AI scene to you. That's exactly what we're doing. In fact, we made it const because we're not going to change it. We're just going to extract data and store it in our own data structures for the vertices and the indices data on the model. If the importer is destroyed and the data was created read by it, will be destroyed too. So the easiest way to use the importer is to create an instance locally, use its result, and simply let it go out of scope. So perfect example of resource acquisition is initialization. That's what I like to see. The example is literally what we are doing. In fact, that's exactly what we do in the library. We get our imported instance, we call read file with our file, and all of the bit flags with the bitwise OR. Nice, whatever, what can I say? Yeah. If the import fail, in our case, we don't compare with null pointer, we just make the implicit comparison in the if. It does the error logging, imported get error string. I do believe it's doing that as well, right? Yep, imported get error string and return false. In our case, though, we can return false. Now, the possible reasons why it could fail, what are those? Because if there's some possible reasons by which it could fail that is related to something like semi-non-deterministic reasons that could happen to be a one-off thing, then it's worth throwing an exception that is caught inside fictpot. And if it's that specific type of exception, then we can just let it go so that mesh is still 0, and so next time it gets called, it tries again, and then it successfully does. So not throw back the exception, back up the stack, call the stack frame allocations, and instead handle it within it. So like stop handling the exception. So like say the exception is done within this try block in fictpot, instead of throwing back up as we do if we have a file system error, which is indeed unrecoverable from within this function in particular. All right. What exactly is read from the files and how to interpret it is described in the ref AI data. I love it when documentation has things like this where it's probably supposed to be clickable or something, but it's it's not clickable. The post-processing steps that the async library can apply to the imported data are listed at AI post-process steps. See the ref pp post-processing page for more details. Note that the AI scene data structure returned is declared const. Yes, you can get rid of these 5 letters with a simple cast. Yes, you may do that. No, it's not recommended, and it's suicide in dynamic library loading builds. Is that the actual acronym? Is it dynamic library loading? Or is it, I know it's for sure dynamic library, but I don't know what last L stood for. Builds, have you tried to use in your delete or any of the arrays in the scene? Sure. I don't really care about this, and I don't really care about using custom IO logic. Sure, in the same folder, standard IO logic is used. If your application works in a special environment where you need custom logic, you have to change it. Using custom IO logic, whatever. Logging, I mean, not really. What can I say? Exporting models, don't care. Data structures. What's the indices for the data structures? Node hierarchy, meshes, materials, and textures. No, don't care. Material system, no, I don't care about this either. Animation overview, nope. Performance, don't care about it either. Importer nodes, I don't care about it either. Uh, uh, this is just if you want to implement an importer yourself. Pretty confident. Appendix A has template for base importers abstract methods. Alright, I suppose. After the import of your asset is done, you can apply configurables. You can apply a configurable set of post-processing operations onto your data. Name, description, AI process, call tangent space. Compute the tangents and bit tangents for the imported cache message. So those are the bit flags, right? Yeah. I'm going to assume it's not going to throw, right? Apparently the API documentation is empty, so whatever you click, it doesn't really link anywhere. And if I look at the page source, it's, yeah, it's this. Well, whatever. What can I say? I'm going to assume, based on the fact that I couldn't find any official info and I don't want to bother looking anymore, that whatever exception any other exception it throws, it's fatal, and we're gonna throw it back up the stack, and we're not gonna handle it back up the stack, and we're gonna let the program call std terminate because it realizes we've already wound the entire stack. No exception handling. Done for. It's done for. So once that is done, we are going to move on to the next function where I'm likely going to have to, well, maybe I'm going to have to change the description because this in fact throws two exceptions. So the first one is going to be who knows what exception, or rather, let's start with the file system one. Documentation is going to be this, and we're going to say the file couldn't be found. So the second one is going to be a general exception, which is just exception in general. I could just go ahead and make it ... So any other exception, considering it's just well, you're just catching some exception. I mean, technically it's not the same because you could have an exception that is not a derived class from the std exception base class. So dot 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 would catch those and not std exception. Let's leave it the way it is, basically. And cross fingers, the teacher is okay with my changes to the libraries. So, unknown exception, basically. Uh, no. No such thing as a precondition because there's really no precondition on the function itself. Sure. Sure. So basically, I just said there that we're throwing again the exceptions if something happens, back up some higher stack frame, and yeah, handle it whatever the fuck you want to do with it, and yeah, that's it. Figure airplane is gonna basically need the same things, which is we say that we're gonna have a new catch. That's gonna be a file system error address of. We reported through CR, so EWAT, and we're gonna throw again. We're gonna throw again, and what the hell am I doing? There we go. Low battery. Alright, whatever. Then I have to make the same call. So same there. I gotta expand the documentation. There we go. So does that, and does that. Now, I don't want to check out what I said I wanted to check out, but it turned out I didn't. So CLog is not there. Stream, not there. Let me go into the index. Let me go into CLog. So with the C, we go down to the L, and we go into CLog, where it's apparently only treated on 2 pages, page 6 and page 46. OStream object tied to the standard error. By default, watch CLog are buffered, usually used to report information about program execution. So indeed, it's specified, give it the end line, so it inputs the new line and flushes the buffer. Nice. For CR, not the case. It already flushes for every write, so no need for that. Yeah. Gonna throw again. I think that's nice. Next thing is going to be looking up the next function, which basically makes the unit arrow. So what do we have here? Friend. We are making the unit arrow. Yeah. Basically, this just used two methods to make the unit arrow. First, it used the pyramid method. I mean, it's not the pyramid; it's the cone. Basically, it's the same as using a prism, but with a high precision for the base, so that it looks like a little nice circle, and with a single vertex as the top vertex, so you end up with a cone basically. And then you increase the resolution of the slices on the base so that it looks more of a circle and less of a pyramid. Then of course you have to make that larger than the radius of the prism. That does have to be a prism, so same base on both top and bottom. It has to be akin to a circle, so circle, big approximation to a circle based on a polygon. And yeah, basically the parameters determine that. The slices, shaft radius, head radius, and head length. So head length gets you the length from the, we use a triangle fan for the bases, so it's from the vertex that is shared by all triangles and a triangle fan at the base of the cone up to the top of the, god damn it, the top of the cone, that is 0.20. And then the head radius is basically the radius between the the vertex that is shared by all by all triangles according to the indices vector in the triangle fan that is used for the base of the cone, has a head radius of 0.045. And then the shaft radius is 0.015 because it's even smaller than the head radius, because we want to have like a prism, and then we want the head of the shape to have a larger radius so that it actually looks like an arrow, because it's a cone that has a bigger base than the prism on which it stands, and that is an arrow basically. So yeah, does that. I documented everything nicely. Nicely formatted everything, or basically configured the formatter and told clang format, do it for me. That's it. This basically uses mathematical assumptions that I am not going to explain because it would take me too long. But it's not hard. It's all very, very straightforward. Yeah. Answers that one. Sure. Goes ahead, binds it, draws the VBO, or rather, loads the VBO, loads the EBO, so vertices data, index data, loads the position. Remember, vertex attribute array 0 is the one that we associate with position. With when we use a mesh, as we use in this case, then we have normals as attribute 2 and UV texture coordinates as attribute 3. I mean, third attribute, so attribute 2. Then we unbound it, we update the index count, we return the mesh, whatever, who gives a fuck. Yeah, it does what it's supposed to do, basically. That's all I gotta say. Not much about this either. Draws axis arrows, uses the previous function to first update the uniform of the model transformation matrix, and then the color uniform, so that we always give it a certain color of green, for the y-axis, red for the x-axis, blue for the z-axis, and it uses scopes to update the uniform. It backs up first the scene projection matrix, which uses in all cases an orthographic projection matrix, not a perspective projection. So it's a lot simpler, and I am thankful for that. Really, I am thankful for that. It basically updates the color by updating the color uniform with this call. Then it calls draw elements with that. Does the same thing with all the others, but of course, it has to use a different model because it's got to rotate everything except for the z-axis. The z-axis is the one that points towards us. That's the one that is Gucci, that is perfect. The other ones are the ones that we gotta rotate. Of course, if we had built if we had changed basically the order of some of the parameters for x, y, and z when building a single one of those unit arrows, the order of those rotations would have been different. So if maybe we would have had this block on z, and that simple block on z could have been on the x-axis. But yeah, it's this way, and it's gonna be this way. It's gonna be one simple to complex, so it doesn't matter which one is it really. Then it loads back up the projection matrix, and yeah, that's it basically. Yeah. Wait, what? That's not a projection matrix, right? That is the model's uniform. Then you've got the viewport uniform, and the actual projection matrix. Alright, I'm going to ignore it and assume everything is working alright. Yeah, that's all I gotta say. Create mesh takes the mesh, takes a lot of other things by doing this, so that then it's easier to create the meshes and everything when I'm using building the unit cylinder, unit cube, unit sphere, yeah, all of those things. For the unit sphere, you just use a sphere. For the other ones, simple methods, no isosphere, or was it Goldberg formula? I think it was Goldberg formula, the other possible one, the other popular possible way of building the sphere. Alright, sure. So, creates the mesh, another with indices, gets the mesh, gets the vertices, gets the indices. If MVAO happens to be 0, then return, because this basically means it's already got a unique identifier. I mean, no. Creates a mesh only if the mesh hasn't already been created. That is, we don't already have some static piece of data with a mesh. So yeah, it does that basically. Binds it, makes the array. I'd say it's alright. I could improve some things there, just as I did on the load model importer. I don't know if I can improve anything here though, so... Oh, now that I think about it, I can improve some things here as well. Not here though, but maybe here. There exists a possibility. Yeah, I can make it less type dependent and more general. So technically there I'm loading vertex data. Instead of just saying size of float, I can say size of declaration type of vert value type, which is float. But it's like it more tightly refers to the idea that we're using the value type of the vector where we have the vertices. And you don't have to like go back to vertices, check that indeed the value type is float and blah blah blah, yada yada yada. So, a declaration type of vert value type, which evaluates the float. Then same applies for this. We do declaration type of IDX, value type, and that's nice. There's that, which I like a lot. That's done. It'd be nice if I replaced the cosines and sine functions of the standard library with God damn it. Also, those casts to an assigned end, I mean, technically they're cast to the value type of the IDX vector, and that's why I have to cast them. Such a pain in the ass. I'm gonna have to make multiple passes through this file, fixing different things that I pass through it. But for now, I'm not gonna fix it. Maybe I am, because I'm not even that. The file is big. It's like almost 1,000 lines. So, yeah. May as well change it here. The size type gets me that. I get the value type for that. I got an AI vector 3D, whatever, sure. I do make the changes there to indices value type, so at least I did it here, so I suppose it's a good idea that I do it everywhere else. So yeah. Next one's gonna be, yeah. There's a ton of static casts I'm doing here to types that are like apparently unrelated to a current context, even though, I mean, clearly they're related because I'm creating a float variable, so I need to pass this to float to get a non-integer / non-Euclidean division. Alright, I don't like it because this is gonna get so big. I'm on my way. I'm on my way. Wait a second. Wait. Uh, I'm gonna take a wee little break, and that means I'm gonna stop the stream and drink some water, and I'll be back at some point.